Okay, this is the P4 paper from January 2024. It's question number 2. It's a partial fractions for the first part here, and then the second part is going to be integration, but using partial fractions. So relatively straightforward. Let's make a start on it. Part A then says we've got 3x plus 4 all divided by x minus 2, 2x plus 1 squared, and then they've been kind enough to break it down into the partial fractions for me. So a over x minus 2, b over 2x plus 1, this is a repeated factor, c over 2x plus 1 squared. So they've done the difficult bit for us really. What I now need to do when I'm adding these three fractions together is I want the common denominator here to be x minus 2, 2x plus 1 squared. So if I'm going to do that, you can do this as slowly or as quickly as you want to do. I'm going to say a, it's going to be 2x plus 1 squared over x minus 2, 2x plus 1 squared. Now you could just do this all immediately in one go here. I'm just slowing it down. Again, if I want 2x plus 1 to have the same, if I want this thing here to be the same common denominator, then I'm going to need to multiply by x minus 2 and 2x plus 1 over the same denominator, and then following exactly the same argument through. For the c, I'm going to need to multiply this one by x minus 2. So again, I end up with that common denominator of x minus 2, 2x plus 1 squared. So what some of you will do, give me a second, is you'll do that straight away and put that all as a 2x plus 1 squared plus b x minus 2, 2x plus 1 plus c x minus 2. Handwriting? Apologies. X minus 2 there. All divided by x minus 2, 2x plus 1 squared. Just depends on how much time you've got in the exam and how careful you want to be when you're showing this work. Should have done enough practice of these, so this is not too difficult at all. Here, I would like to do everything really, really formally. So equating the numerators means I'm going to get those top lines are equal to each other. I'm going to get 3x plus 4 is equal to a 2x plus 1 squared plus b x minus 2, 2x plus 1 and plus c x minus 2. So once we get to this stage, then we can choose to let x equal to whatever I want. I'm going to choose x is going to be equal to 2 because what I want to do, if x is equal to 2, that bit will be 0 and that bit will be 0, and I'll be able to work out what a is. So it's true for any values, but it's certainly true for x equals 2. So if x equals 2, I'd get 6 plus 4, that's 10, is equal to a times putting 2 in there is going to give me 5 squared, and then these two, I'm not even going to bother doing too much calculation for that, it's just going to be 0 and 0 there. 10 is equal to 25a, so a works out to be 2/5 for that one. If I now choose what value do I want so that that works out to be 0 and that works out to be 0, well, that's going to have to be x equals minus a half. I mean, if you're struggling, 2x plus 1 equals 0, 2x equals minus 1, x equals minus a half, but I'd be really quite concerned if you needed me to show you that at this stage. So choose x equals minus a half as my next option for x. So if x is equal to minus a half, then I'm going to get 4 minus 3 over 2, or 4 minus 3 over 2 is 5 over 2 on the left-hand side, and I'm going to get 0, I'm going to get 0, and I'm going to get whatever c works out to be. And it's minus 2.5 c, or in other words, minus 5 over 2 c. I'm really quite pleased at that stage that c works out to be a nice, neat answer there. Now for the last one, you can choose x equals whatever you want and then work it out. But if we choose x equals 0, I just think that's the easiest thing to substitute in. So I always tend to go with x equals 0 if I can, because that's going to give me 4 on the left-hand side. And then I've got a times, well, if x is 0, I've got a times 1 squared. Well, that's just a. If x is 0, I'm going to have here, let's just see what I'm doing up here. If x is 0, I've just got minus 2 times 1 there. Well, minus 2 times 1 is minus 2. B. And the same thing, if I've got x equals 0, that's just minus 2. C there. So it just means that this is a little bit easier to be able to work out what we've got going on there. Remember, we know what A and C are. So 4 is equal to 2/5 minus 2b plus 2 there. I'm just going to tell you what B works out to be. B works out to be minus 4/5 for that. Let's make sure we go back and actually answer the question, because it's... Oh, no, sorry, the question did just say find A, B, and C. So I've worked out those values there. I don't need to go ahead and rewrite out the fraction. I will do for the next part anyway, but I don't need to for that part. Part B then says, hence find the exact value of the integral of... Just a quick check, it's absolutely fine, but just a quick check that they are exactly the same thing. You never know whether they're going to sneak a 2 or something like that in there and just make it that we just need to be a bit careful. But no, we're absolutely fine with this one here at the moment. So the integral, let's write it out now, part B. It's the integral between 12 and 7 of 3x plus 4 all over, it's the same fraction, x minus 2, 2x plus 1 squared. Well, that's going to be the integral of all of those fractions, isn't it? So between 12 and 7, it's going to be putting 2/5 in there, x minus 2, putting 4/5 in there. And I'm going to write it out like this. I might tidy it up and make it look a little bit neater in a minute, but to start off with, and then minus 1, wasn't it? Minus 1 over 2x plus 1. All squared as we're looking in there. So yeah, just checking my values for A, B, and C. dx. Really should have dx here as well there, so just move this over and put dx in there as well. So integrating the left-hand side is the same as integrating the right-hand side, but the right-hand side now I should be able to break down into all the different things. So if I'm going to do that, what I'm going to do is say 2/5 1 over x minus 2, because that will just be a log 1. And then minus 4/5, again between 12 and 7, 1 over 2x plus 1, because again, that's just going to be a log. But then just be careful with this last one. This last one is going to be minus the integral of 2x plus 1 to the minus 2, dx on all of those. And this one, we now just need to take a little bit of time over. The other two are just straightforward log ones. With this one, if we've got this to the power of minus 2, we're doing the reverse chain rule. What you try and do any time where we've got a function to the power of something and we've got the differential of the function out here, then what we can do is the reverse chain rule in effect just says, let's guess what I think the answer is. Well, if I've differentiated and I've ended up with 2x plus 1 to the minus 2, I'm guessing, so in fact, let's just tell the examiner what I'm doing here. I'm doing, sorry, that should be between 12 and 7 up there. I'm doing the integral of 2x plus 1 to the minus 2 dx. And what I'm going to do is say, let me guess that y is equal to 2x plus 1 to the minus 1, because when we differentiate, we multiply by the power and we take 1 off the power, which gives me that. So when we're differentiating one of these functions, multiply by the power, take 1 off the power, multiplied by the differential of what's in here, so multiplied by 2 there. That means that the differential of my guess is minus 2x plus 1 to the minus 2. So I can now factor in that if that's the integral of this one, when I want to, sorry, that's a differential of this one. When I'm differentiating that way, if I want to integrate that way, then what I'm going to do is say minus a half to take account for that minus 2 in there. So if we now go and do all of the parts of the integration, so I'm sort of jumping down here now with my answer, I'm going to get that the answer is 2/5 log x minus 2, that's the integral of this bit here, minus 4/5 log 2x plus 1. Now, because of that 2x plus 1, we have to also put a half in there. If I just move that over, I'm going to have a half in there. And then for the last part, we've done the most work on that, that's just a half, was a minus, so it becomes plus a half of 2x plus 1 to the minus 1. So all of that now is going to be between 12 and 7. So lots of places where you could make a mistake there. Just take a little bit of time over doing that. I still haven't finished, so if I want to tidy this up now, what I can do is to look at this and then say, right, if I take 2/5 out as a factor for this first part here, I'll get left with log x minus 2 minus log 2x plus 1. Remember that's going to work out to be 2/5, that part there. So I've got that bit all plus 1 over 2x plus 1. Now you can leave it like that, or what I'm actually going to do, I'm going to call that 1 over 4x plus 2. I'm actually going to tidy that up because I'm going to be putting values in a minute, and I want this to be as neat and tidy as possible before I start putting my values in. So now all I've got to do is put 12 and 7 into those, or in fact, no, actually, let's do one more step. Let's, before we do that, then say this is log, turn that into one fraction here, x minus 2 over 2x plus 1. I'm just trying to save myself a little bit of time when I'm doing any of the values here, just so that I'm more likely not to make a mistake once I sub these values in. You could have subbed the values in right there if you wanted to. It's entirely up to you. It's all personal choice here. But now if I'm putting these in, I'm going to get, putting 12 in, I think is going to give me 2/5 log, well, that's 10 and that's 25. Please just tidy up that handwriting there. So 2/5 log 10 over 25 plus putting 12 in there will give me 1 over 50. So it's that minus, now putting the 7 in, gives me 2/5 log, that actually works out to be 5 over 15, and that works out to be plus a 30th. Again, remember, there's the minus of all of that. And then if we do that, I've got log of A minus log of B, so I can do A divided by B here. I'm not going to spend much more time on this. That actually works out to be 2/5 log 6 over 5 if you combine those two, and then plus 50, plus a 50th, sorry, minus a 30th. If you do that, again, you can do it on the calculator. That works out to be minus 1 over 75. Let's just go and see what they said about the answer. No, oh, okay, right, yeah, okay. In this format, P log Q plus R, where P, Q, and R are rational numbers. So yeah, I've got P, that's 2/5. I've got Q, that's 6 over 5, and I've got R as being minus 1 over 75. I think it would be nice if they'd actually say, can you prove it's equal to that? Then I'd feel a lot better when I'm going on to the next question. But that's up to the examiners. Right, a lot of work there, but hopefully that all makes sense to you.